Yeah, thank you everyone. Thank you everyone for coming. So I'm Jason. Somebody you may not me. It doesn't matter. I will introduce myself. So the presentation I'm doing today is called internal AI interaction, elevating human computer interaction, which all of us are working on to the internal and conceptual level. So in case you are not knowing me, first year PhD student with Joe. That's a very amazing journey. We explore so many things with our interns. And I publish on EMLP, TI, CSW, CNC. I intern with Microsoft Research, MIT IBM Lab. I also data miner. I've also introduced one work I did in data miner internship. And I also serve as a PC member for CNC IUI and also review 30 papers, more than 30 papers. So here is the story. So now living in the generative AI that's this blooming this era, and we are always considering one question: is how can we better design AI tools so AI becomes the baseline of human capabilities? That augment our capabilities. It's not let's try to automate everything and ourselves and becomes the upper limit of humanity. So that's a question we really care about. Is how to design better AI tools to better support people, to make people to do more things. So to answer this question, we need to computers. That's all. That's the computer in the HCI. So we have the command line interface, which is a very original classic one. We still use that now. And then we have GUI, which Apple, Microsoft has just leverage these GUI representations and also direct manipulation. So for example, if we want to open a folder, we can just double click, we can drag and drop the folder. And now we have the generative AI, and that's still in the command line shape. For example, we have inputs and we have outputs. So if we want to this and it go back to command again. So maybe what's the next step? So we want to type this momentum, go to GUI for generative AI again. However, that's what we did. So that's how the ChatGPT started 2 years ago. Yeah, that's November, just exactly this time 2 years ago. And that's how it looks like now. No difference between those two interfaces. There's no GUI, there's no other new stuff on it. Definitely the model improves a lot. They have the reasoning stuff, they have O1, but the interface looks exactly the same. So the chatbot remains a dominant interface for accommodate very diverse user intent. For your intent could be write a paper, polish some stuff, or write an email for you. The intent is very diverse. But the chatbot is just serve as the all-in-one stuff tool as a AI tool. Moreover, we saw the generative AI. This time chatbot. For example, that's a Claude. So that's a computer used from Claude. So it can even operate on our GUI. We have this interface. This our desktop, and to issue a query on the left. So please search for the HCIL. Tell me something about UMD HCIL. And if we tell something on that in the chatbot, it's starting surfing on the GUI. So it uses the needs of human to operate on the GUI. For example, it will take a screenshot. It will just open the browser. They will type in the query. That's humans. Yeah, you will see that then it's starting to type in the query. Search for UMD HCL. And they can also use some bash command to save some stuff. You can also scroll down the interface. Yeah, it can also scroll down the interface. Then we saw the draw. Yeah. Yes, definitely. So currently we are in a very big paradigm shift from this kind of support command line based to this kind of int. So the command base is GUI have the direct manipulation. We can click off idea is that we just encode the command into a button and we put a indicate for the yeah. So some other items let's do some things. So that's still very command, those command. And then we impose those command into the buttons. However, the in is just that we just type in something we want to do. Like we type in, just use natural language. I just know that don't that to open the HCIL or that's any so it's just like based on our very high level intent. So let's just to give some definition of what is command, what is intent. It's that's so the command is a very concrete, predefined action for direct execution. So one example is for document, if you just click the button, so an intent is much more high level. That's a high level require reasoning to execute. So some class the intent, but that's very command. It's very precise. Or that we need to reason like what does it mean to do those things. For example, the intent could be make payment with our clients. Then the question, there's so many. So what is what is for our clients? So all those things that they need to refer. Okay, so that's my clients is something looks great means something very specific things is in this context. So we need to do to multi-step that to identify how to make that things before execution. So that's a difference between command and intent. And another example is that, for example, that key kind of and that's icons and also that checkbox. You can indicate that. So if you want to just check all those filters and also click a car. So that's very precise, very low level. In lab intern is very vague, it's very high level, but that's all the things we are doing every day. For example, like if we use the full famous code, if I ask what our customer what do they want, they will just say that I want a fast house because they never seen a car. That's why like they just want to get a faster house. But the process is that when the end user expresses the intent, they want to get a faster house. Like there are some reasons. Okay, let's they want to get a faster house. So it's a quick and efficient way to get one for transportations. Then it can just try to do some reasoning. Okay, do you want to get a car? That's how to get a car. So then that's the executions. So that's kind of the intent AI interactions. So that's with language models can just put human control or human manipulation on this kind of the intent level. You can just say something like I want the first house. Then the language model will just do the execution, do the reasoning and the executions. So based on that, the reduce the command level control and also have more conceptual level interactions. And also based on that, we want to make some user interface for the intent exploration and also evaluations. That's all those operations, all those like interface, those representations is based on the intent level, not on the command level. So let's start from the first one, the reduced command level control. So if we use this kind of framework, right? So command level control is more like doing things right. For example, if we want to work on the Word document, if we want to make it looks good, we need to click buttons in the right way. We need to click the button, click the left align button, good. So that's like doing the right thing. It's like doing things right, doing things in the correct way. But now the language model has a kind of encoded knowledge or encoded like human mechanisms of how to do things right. So agentic workflows, so the AI can just like show very strong potential doing things right. Now it can do data, it can do the data visualizations, it can do coding, and also actually writing all those stuff. Yeah. No, it works now. It's just, I just use my microphone. Okay. Okay, yeah, sounds good. Okay. So let's the first work showing the reduced command level control is in news headline generation. That's from my first internship. So we published this paper in MLP last year. So that's my first company I intern with. It's called Data Miner. So the business they are doing is they are doing real-time alert. For example, we know there are many news are happening. So how do we know those news? So those companies doing data mining, try to monitor the whole internet and also monitor social medias to get a real-time alert. For example, for the elections, what's kind of the current status. So that's business they are doing, and their clients including definitely news medias and also business investment banks, something like that. That's the businesses they are doing. They just catch all the data on the internet, and then they just the data mining and send the alert, real-time alert. For example, that's something that's happening. So to the news media, to the public sectors, to the finance. Then the things I'm doing because I'm not working on data mining. I'm working on human computer interactions. So the things that I'm doing is I'm working on how to human AI co-creation of the news headlines. For example, because they have many clients working on news medias. So if they get some information, we want to get a very quick a clear summary of the data or the news. So I'm working on how to have both human very experts human editors and also the AIs the language model to generate some very good news headlines based on a news article. And we design multiple conditions for that. We have the AI only because that time is 2 years ago. That's summer 2022. And we have the GPT 3.5, the DaVinci 002, the AI only condition. So there's no human expert, no human control, no human effort. Then we have a little bit more human control. So that's a selection. It's we have a news article and we have the AI to generate three possible candidates of the news headlines. Then we have the human to select one of them. Because maybe some of them, because 2 years ago, we don't really trust language models. There are some very trustworthy issues because news headline should be very trustworthy, has good taste, and also attractive, those things. So we have human editors to select one of them. Then we have even more human control, which is guidance plus selection. The guidance means before generating the news headlines with language models, we use a language model to generate the keywords, that's the facets of a news headlines and of the news articles. And that's also how experts editors doing, because before get a news headlines, they will try to get some keywords, then they compose those keywords into a news headlines. So we first use a language model to generate those keywords, and then we have the human to select the keywords. Does these keywords make sense or not? And then before select the keywords, the human also need to read through the news articles. Then they select those keywords, and then human select. Then the language model will use the human selected keywords to generate multiple headlines. Then human selects one of the headline again. And we have even more human control is plus guidance selection plus post editing. It's after the human selects the best news headlines, they can still also post edit. For example, they can still polish the headline. They can still add some words or delete some words. Then the last one is manual only. That's just pure human working on the news headlines. As the classic version. So we have the two space. One is mainly for the selection. It's a headline space. One is a perspective space. It's the guidance. So we use the language model to select the keyword to extract the keywords. Then they use the select keywords to generate the news headlines. So we have two baseline conditions. So we have the headlines used by online media. So we use best news article headlines, the best news article websites, the Yahoo News, and also headlines generated by GPT 3.5. So that's two kind of baselines. We have four human direct manipulation conditions, the headlines written by professionals or with only selections, or both guidance and selection, guidance selection, and post editing. So we did a very large scale study. So we have we said 20 articles from multiple domains, because the domain will also influence maybe the nature of the news headlines. We just use sports, science, world news. We try to avoid politics. And then so we have two baseline conditions that in 20 articles. So that's 20 headlines uh, for each condition. And then for human conditions, because humans they also have some variance. For example, one good headline in one individual's mind maybe is different for another one. So we are to overcome the individual variance, individual difference. We also recruit for all the human conditions. We recruit 10 participants for each condition, and let's say we'll work on those 20 articles. And then all those headlines, those 840 headlines, they will be evaluated by 20 professionals, other editors. And then we end up with 20 articles, and we have 6 conditions, and then we have 20 evaluators, 2,400 ratings. And then the result is we found that two baseline conditions outperform all the human conditions, which means that the headline generated by GPT and also the original golden standard news headlines, they outperform all the human control conditions. For example, for the manual only, so the manual only that's worse, but it also makes sense because we only have a very minimal time for that. Yeah, question. What's your performance metric for this? Okay, yeah. So the performance metrics is that we just has a human evaluations, and we have guidance of how to evaluate those news headlines. It's called TACT. That's taste, attractiveness, clarity, and trustfulness. And we just pass that to another set of human editors to evaluate these news headlines. But it's mainly for human evaluation. Yes. Clarity and trustworthiness. Clarity, trustworthiness, attractiveness, and also taste. Yeah. Yeah, but we just combine all of them because we don't want to have 4 different dimension metrics for that because that's too much. We already have so many news headlines. Yeah, so we just bundle all of them and then we just have one single evaluation for that. Okay. So the rating process is that we just show 6 news headlines for the same news article, and they are all from different conditions. And then they will rank those 6 headlines from 1 to 6. 1 is the best, 6 is the worst. So if they have the one condition got more 1, which means this condition is more promising than the others.
Sorry, one last question. So they're evaluating the headlines. Were they evaluating it with in conjunction with the article?
Yeah. Definitely. Yeah, we also provide the original news article to them because without the news article, they cannot evaluate the headline. They don't have the grounding. Yeah. Yeah. Thank you for that question. Yes. So the result is that we found those 2 baseline conditions outperform all the human direct manipulation headlines, which means that the golden standard, the Yahoo News, definitely that's the best. Maybe the editor spent 2 days to work on one article to generate a good headline. But for the GPT, it just use 1 second to do that. So that's quite promising. And at that time, because that's just 2 years ago, the summer of 2 years ago. And there are many leadership or managers in the company doesn't trust that. Okay, they can understand the news headline from the language model. That's pretty good, but they are just confused by why the news headline selected by the people is still worse than without selection, just generate one single one. But now we understand because now the first thing we know now after 2 years is the first language model is very good at this kind of fluency, just text summarization, this kind of content curation task. The second one is that definitely human will add some bias to that. So the best headline selected by one people maybe not just be seen as another good one for another evaluator. Yeah, like that. So that's the results for but we also have many other benchmark or rankings. For example, we also have that time spent but definitely for large models there's no human labor. There's a time spent on that is just 0. So and also that trustworthy is something like that. But just in general, the language model perform very good on this task. So for example, for the original for the original condition, there are 87 of them ranked as 1. So that makes sense because that's definitely the best one. And the worst one, for the original condition, only 38 of them ranked as the worst. So that's a GPT only. So we can see the best one is that that's less than the original condition, but that's the worst is that almost the same as the original condition, which means the GPT is it doesn't have like so much serendipity, like a very good news headlines, but it has it's very stable. It doesn't have very bad news headlines. So for this kind of news headline generation, if we don't really need so much serendipity because for the news media, the production is quite like a mass production. They just produce many news headlines. So for this type of task, large model shows very promising. Maybe for a book title, maybe we still need more human labor. We can just randomly generate one the working title for a book. But for news headlines, that's definitely the current state of the art, and it's used by the industry. And after that, so we are seeing many things changing in the news industries. So the work is done in summer 2022. And in the summer 2023, the CEO and also the chief AI scientist read an article just very similar to my paper title. The chief scientist is also one author of that. So harnessing the power of large models and multimodal foundation models in the AI platform. And 1 month after, they are starting to lay off people who are originally working on this kind of fact checking or news or highlights those kind of stuff because now they can just be automated by language models. And this year in April this year, they even launched a new thing, a new language model called regenerative model. Is that because the news is definitely is evolving through time. For example, for the elections, for the stuff, and every day there are some new stuff happening, and they just develop these models try to, for example, when things as the news evolving, it can automatically regenerate the news or some information, some the kind of summarizations based on the news things. So it's always keep regenerating, keep regenerating. It's just no human human in the loop, human endeavors in that. So it's what's very efficient, and it definitely will change the news industries, things like that. Because for this time, the timing is more important than the quality. Yeah. So for the first word, we are showing kind of reduced the needs of command level control. So but if we are as humans, if we are not doing the command level control, what should we do? We can just not do nothing, right? So we still need to work on something. So the idea is that as humans need to shift from this kind of command level control to the conceptual level control. That we can still leverage those AI systems, leverage those large models, and we can just express our ideas, our intents, the concept to that, and make sure it knows that there's some alignment, and it can know what we want to do, and it can just try to execute the stuff. So the first thing is that if we want to move the human AI interaction to the conceptual level, maybe something will happen is that the human and AI, they will discuss what's the best thing to do. Because previously I mentioned this kind of paradigm is one is doing things right. So that's more like command level. And then one is doing the right thing. Doing the right thing is more like the conceptual level, the inter level. You need to discuss, make the right decisions. So for this type of things, maybe the first thing is that maybe the right decision is not always from the humans. Maybe because at the very beginning, maybe as humans, they don't also know what I want. They may have just a vague idea. For example, the vague idea is that I just want to get a fast horse. They don't know a car. Then when the human discuss this idea with the AI, maybe AI says, okay, maybe you now really want to get a fast horse. You want to get a car. Yeah, okay, the human, okay, what's car? And then AI can explain the car to that. So this kind of conceptual human AI interactions. So that's called human AI ideation, is that doing the right things. So it's actually how human AI they can discuss what's the right thing to do. And then when we settle down, get the right decisions, you can just get an AI to implement that automatically. So that's the next thing I have done with Draw is concept-based interactions for cross-domain analogical thinking. So we published this paper in critical coordination and we got honorable mention. So the thing we did is that first we have a design problem that it's just like it's very practical that we every day we are facing many problems, and when we get a design problem, we want to solve that. But before just get down to the try to find a solution for that, we want to get some inspirations on how to solve the problem. We want to do some better prompt formulation to understand the prompt better, to like derive better solutions for that. So the thing we did is that we use language models. That's still a work from 2 years ago. That's that we just use language models based on design problem. We generate another analogical problem, like an analogy for that. So analogy is basically something is kind of have the like a very different stakeholder, very different context, but has very similar obstacle and goals. So we can learn something from the analogy, analogical problems, try to solve the original problems. So for example, the example I'm giving is a design problem is a high school students, they want to apply for college. And like analogical problem analogy for that is data analysis. Because the commonalities between those two problems is that both high school students want to apply for college, and also data analysis. Both of them they have many like things to consider to make decisions. The high school students need to consider like which major to choose, and also the data analysis think need to think about that. What's the relationship? What's the variables? What's the dominant variables to choose? So they are sharing some commonalities, but they are in very different domains. But then the high school students maybe they can learn something from the data analysis, how they deal with so many variables. So cross-domain analogy has a very creative potential. For example, for the NASA satellite, it has an analogy from origami. So origami is that they have some paperwork and they can just unfold that into a very good shape. So the satellite just borrow that to unfold the satellite into something. And also the other device is that it just uses an analogy from like extracting cork from wine bottles to pour in funds. So they are kind of like draw that some inspiration to more mature domains to borrow some wisdom from those domains. But people often struggle to generate and retrieve cross-domain analogies because that's creativity is hard. And how might we computationally support this kind of cross-domain analogical creativity for people to get more inspirations, make the right ideation? So we use language models to reliably generate the cross-domain analogies, and also what's the benefit and also cost for this kind of analogical creativity with a language model generated analogies. So we did many benchmarking. We just tried different prompting stuff, few shot, one shot, zero shot, and different analogy examples. So that's finalized prompts we have. So first, we have a very concrete prompt for the task. I want you to do something, and we have the inputs. The input is the original design problems, and we want to get it generate the output. That's another design problem, but in another domain. That can serve the analogy. And we also put one shot, so we just give a very good analogy as an example for the language model to learn. So then we generate a bunch of analogies. We also do a very kind of large scale study. But for this kind of analogy, the difference between analogy is the difference between the analogy and the news headline is analogy that you never know whether it's just useful or not before actually using that to redefine your original problem, try to reformulate your original problem. But for news headlines, if we can just get experts and we get right metrics, for example, we just get a TCT, the experts can reliably evaluate the news headlines. But for the analogies, we really need to get an actual designer or people to use that. Then after using that, they will find, okay, it does help me to come up with better ideas, or it doesn't really helps. So for that, we just we design a task to evaluate the usefulness of analogies, but actually trying to use them in a very practical, critical problem reformulation task. The problem reformulation is when they receive an original design problem, then they just try to formulate a problem. For example, what's the problem is talking about, how to solve this problem. Then we just give them the analogy, and after seeing the analogies, they may have some new ideas of the original problem. So they generate the initial formulations, then also generate the idea for design problem. And then we will give them two language model generated analogies, because there are also some variance in analogies. And they will try to map the analogy to a problem. They will attempt to use the analogy to revise their initial understanding formulations of the original problem. And they will reach the happiness of the analogies generated by language models. And that's the results. The results is that most of them, just three is the kind of the average, that's natural. Five is that's useful. Four is kind of useful. Most people found that large model general analogies is useful for them to understand their original problems. So that's quite interesting. It means that on the ideation level, it's not on the execution level. On the ideation level, on the conceptual level, the AI, the language models can still bring some useful things to the human for them to better decide what's the decision to make. So to better know how the analogy is useful for them, we need to code them. So we just code the reformulation response with two codes. One is adding, one is rejecting. The adding is that when they see after they see the analogies, they have some new understanding of the original problems. And the rejecting is after seeing analogies, they have totally different understandings of the original problems. So I can give one example of the adding. Adding is that they elaborating the original problem. For example, the original problem is that the people want to stay at home for a long time, and because of COVID, and they want to travel, but international travel is restricted, and they want to find some interesting place to visit and eat to have fun. But the problem they have is they don't have information and resource to find some interesting places. So for the idea is that they would add some after seeing analogies, they would some person maybe the analogy mention some context of the locations or stuff. So after seeing the analogies, they want to add some specific locations to the problem because the location really influence why they don't get any travel informations, why they don't have enough ideas information. So that's about adding. So one is another one about that's rejecting. The rejecting is that, for example, the original problem is that the stakeholder is owner of travel agencies. Just like from those examples, from this problem you can see that's from 3 years ago. That's during the COVID time. So we are talking about those problems. So the stakeholder is the owner of travel agency. The context is that there are some pandemic and influence that they didn't start operation for a long time. And their goal is they want to reopen their travel business. But the obstacle is that they cannot find enough employees because people already left the travel industry during the pandemic. And after they see the analogy, maybe the analogy talking about monetary, about the budget. And after seeing the analogies, they have some totally new understanding of the problem. So they rejecting the original formulation or the goal or the obstacle. The original obstacle is that they cannot find enough employees because there are no more people in the travel industry. And after seeing the analogies, they say okay, that's not the travel agency cannot find employees. It's actually they cannot afford employees after without money in for a long time without operations. So that's quite interesting. So the original problem is that maybe the solution is that they want to have a better promotion to try to get more people in. But after that, after rejecting, it's just kind of the venture capital issues. So you need to get more money to recruit more people there. So that's kind of helpful for this kind of problem solving process to find what's the right thing to do. And after the coding, we just reached very good at inter-reader reliability, and we found for most of the reformulations, because for the total reformulation response at 220, and for 84% of them, they are adding something because after seeing the analogies, they are adding some new things, like, for example, locations or other constraints to the original problem. And also for 10% of them, they are even rejecting the original problem. Yeah, question.
Yeah, just a clarity. So the first example, the analogy was actually helping, but in the second one, it was not. So
Oh, that's for the second one. It's also helping. It's to just have them to redefine or re-understand, just look at the problem in a new way. So that's even kind of more helpful. Right. That's that. So I mean, like, so rejecting is that they are not rejecting the analogy. They are not finding the analogy that's not useful. They are finding that the original obstacle that's problematic. The original part, for example, as I mentioned, the original obstacle is that they cannot find enough employees, so they cannot reopen their travel agency. But after seeing the analysis, they found, okay, so the obstacle is not really they cannot find enough employees. It's that they don't have enough money to recruit those employees.
Oh, okay. So
Yeah.
what is essentially happening here is that the analogy is helping to look at the problem from a different.
Yeah, in a different way, and maybe in an even more helpful way.
Makes.
So they can kind of identify what's the root cause of the problem to try to identify better solutions. Only when after they have a very good understanding, for example, they understand the problem for on a level is that there's not that about that promotion, that's about that the budget. Then they can just try to solve the problem better. Yeah. So that's not the human AI is happening all this stuff. It's kind of problem solving, like yeah.
Better.
Yeah.
Thank you so much.
Yeah, for sure. Good question. Because as we know that adding is quite easy because you are adding some like features, adding some like constraints, adding some objectives to the original problem. That's quite easy. So that's 84% of them is doing that. However, for rejecting, that's kind of like very hard because it's very hard to give you a very new perspective of the original problem. So but still like 10% of them they are doing that. So it's kind of like for most of them, that's over 80% for majority of them, the language model can have to add some new information details to the original problem. And also for 10% of them, they can even redefine, have them have a very fresh root of the problem. Yeah. And also that's all those 10% of them, that's when they are doing the rejecting, most of them they are also doing adding because if they are rejecting something, they are also want to add something. For example, the thing they reject is that's not a promotion problem, that's a budget problem. So the budget is that's the thing they are adding to. We also did some like harmful analysis because we want to make sure the language model is doing like things like in a good way. It doesn't generate some like bad analysis, but like actually it's also like it's still doing something like that. And also, for example, there are kind of like a few cases. It's generating some like illegal cases. So one is that one bootlegger that's they are trying to avoid getting caught by the police. Yeah, for those things. And also some bias like the people in Africa like that. So we want to avoid that. So that's definitely like a new like problem for improve the language models. But this work is done like 2 years ago when we just have a 3.5. Now it's getting much better after 2 years. So after that, we have discussed that reduce command level of control, and we decided that's conceptual level interactions, human AI ideations. Then that's the next thing is that when we get just so that's the conceptual level interaction is that human AI that discussing one idea, one problem. But we definitely want to have the scaling law of the ideas, of the concepts, of the intents. So how do we have that kind of like a replication maybe in GUI to present more ideas, more intents to support the internal exploration and also evaluations. So the idea is that we from the second study we have shown that AI has a capability to work on the ideas, not just only work on the executions. But then we can just use better ways. For example, they can evaluate how good the idea is, how good the intent is. It's for people to choose to select like that. So that's kind of the scaling a lot of ideas. Previously, in the pre-slide, like the human AI, they are working on one idea, one problem. Now we are working on multiple ideas, multiple problems. And the domain we choose is data analysis. Because for data analysis, we have some grounding. It's not just as design problem. Design problem, we can do anything, but for the data analysis, like, they need to work on the hypothesis, data, results, like that. So we want to build some interface GUI to support the GUIs for intent and concepts rather than just commands to work on those kind of many ideas, multiple things. So then that's kind of the things I'm working on. I have been working on for like 1 year from my medical research internship, the IBM research internship. I'm still working on that in my dissertations. There are some paper under submissions. There are some pattern on some missions. Yeah, so that actually can just kind of introduce the kind of the high level my interns in this study, but I cannot really show very concrete artifacts. So that's one study I did last year this time. So this one is for we build a canvas and so we just let people to issue their analysis intent. For example, what they want to see, what's kind of a relationship trends they want to see, and we just generate those visualizations based on their prompts, those intents. And they can also curate those visualizations in this space. For example, they can drag and drop, they can move the visualization around like that. And we also have a very huge displays for that. That's the thing we did is that we just help people to get rid of all the polishing the visualizations, to tweak those visualizations, change the scales from normal scales to large scales. We just have them to express the scale plot of something, and they can just generate visualizations. You can after they see the visualizations, you can also iterate on the visualizations. That's just a kind of a formative study, and based on that, I'm diving into that. For example, because this one we didn't provide any structures, and that's just a kind of a canvas for ChatGPT. If we want to build it even further, so we need to see existing generative AI powered data analysis tools. So this one is from Try this year. This one is from IOI this year. So this one is they just use a prompt on top of that, and they just use a prompt to generate the visualizations, and it also generates based on the visualizations, based on the prompts. It's also generates adaptive user interface. This is the toolbar on the left, on the right. It's just adaptive to the visualizations. It's also automatically generated. So for example, when we have this kind of line charts in two colors, they can still use those kind of toolbar to quickly polish that. So this adaptive user interface is very highly correlated to the line chart, to the visualizations, which makes editing, polish, iterating on the visualization quite easy. That's about this one. For example, they issue a command and then they generate a visualization. Then they tweak the visualization with this adaptive UI. Then they iterate the process, issue command, then they just tweak with this kind of automatically adaptive ephemeral user interface. And this one is that they run the chatbot and also a GUI together. For example, a chatbot we are very familiar. It's just like a ChatGPT chatbot interface. And also the GUI is that, for example, when they issue some a command or intent in a chatbot, the GUI is also automatically morphed or changed. For example, in a chatbot, we can issue something I want to say some data set. I want to say data set about something, and then it just show multiple buttons of different data sets. Then the user can just directly select the data set, the buttons. They don't need to type in all the stuff. So they are kind of using this kind of semantic control on the GUI. So that's the conversational control on the GUI. But if we want to map that to some paradigm of data analysis, so there are two loops of data analysis. One is a hypothesis refinement loop, because we are always working on research questions hypothesis. So that's one hypothesis refinement loop is we have some initial hypothesis, like conceptual hypothesis. Then we try to do some studies to evaluate our hypothesis. Another loop is a model implementation loop. The model implementation loop is that we just work on the visualization statistics. And if we map those to work, so this one, we issue a command and we generate some visualizations, and also we tweak the visualizations. It's more like happening in the model implementation loop. For example, we issue a command, we have the tweak. And for this kind of blending, the chatbot and also the GUI, it's mainly happening on from all the way, but in a linear way, all the way from the intent to the tweak, to the command, to the tweaks. For example, data say, okay, I want to figure out something, I want to dive into this data set, and then they can just even also polish the visualizations that in this kind of space, like in the chatbot. For example, I want the visualizations looking in this way, something like that. But they miss the iteration process in the hypothesis refinement loop. And as we are seeing because from the pre-studies, we are seeing that the language model showing very strong capabilities in this type of model in the implementation loop, in the execution loop. So that's the human AI collaboration should happens more in the hypothesis refinement loop instead of the execution loop. So if we just not just going down from the hypothesis to the tweaks, if we just stay in the hypothesis iterations, we can maybe have some original intent is reasons of income inequality, and then we iterate on the hypothesis. We make that a little bit complex and also more novel. For example, from the reasons of income inequality, that's very vague, that's very high level. Then we have the simple hypothesis, maybe education attainment is that's a variable, a predictor of the income inequality. And then we can even make that more specific. That's always the things that we done for the research hypothesis. Is that we are adding more variables, for example, the relationship of the education and also income that's kind of non-linear in some certain stage, and just more something like that. So we are trying to refine those hypotheses, make that more normal and also more executable. We can also evaluate those hypotheses automatically. For example, if we just try to compare those two hypotheses, one is educational attainment, one is the kind of relationship with nonlinear, also different degrees, early years. So for this one, the novelty is that so they are all from O1 reasoning. So the novelty for the first one is kind of very low or moderate, because people already know education is one variable. Education level will influence the income. But for this one, the novelty is much higher than this one if we compare those two. And for the feasibility for the first one, it's very feasible to do that, because that's quite straightforward. We can just do a correlation. Try to do a linear regression on that. But for the second one, that's definitely the feasibility is kind of a little bit lower than the first one. It's still very feasible. We have the data, we have the education level, we have the income, but the feasibility is getting kind of a little bit lower. And if we can want to rank those two hypotheses, we can have two matrix, two axes. One is novelty, one is feasibility. So we can see for the novelty, the second one is higher than the first one. For the feasibility, the first one is higher than the second one. So, and if we just do the scaling law of the hypothesis, and we have one intent is we want to understand the reasons of income inequality, and we just generate multiple hypotheses, then we can just efficiently evaluate that with that kind of matrix. Now we are just showing a 2D dimension, but definitely we can just showing multiple dimensions with different color coding with different size. And also actually for exploration, we also have many things with, but for the exploration, we maybe use some other structures. But with this type of quadratic matrix, it's mainly used for evaluations. Because for the hypothesis evaluation part, there's a pattern SMU with IBM, so I cannot really talk about that. But for this one, it's more about the hypothesis evaluation. And with that, we can just do all the good things, beautiful things we are doing with GUI currently. For example, we can drag and drop the idea. For example, if we really like this hypothesis, that's very interesting, but the feasibility is very low. We still want to work on this hypothesis, but we can just drag it a little bit to here or somewhere. Then the language model can just polish, iterate on the hypothesis. For example, if we just drag it here to here, maybe the novelty it will sacrifice not the novelty, but it will just improve the feasibility. So we can actually work on that. And maybe if we drag the hypothesis from here to here, and we have some generative workflows, some agents that can try to acquire or forage new data sets, new information. Maybe the results of the iterative hypothesis after the evaluation will happen on something here. But it just be more information, so the hypothesis is more feasible. We can work on that. We have automatic generative workflow on to work on it, but that's still very novel. So then that's human AI interactions or human AI ideations mainly happens on this kind of conceptual level. So after we discuss those three things, we can see that the command-based GUI will decrease That's kind of along with the reduced command level control, and the human AI intelligence will increase, and also the idea intent-based GUI will also increase. And it's not only happens in the data analysis domain. It will happen in every domain with like human AI collaborations. It will happen in scientific domain. Maybe you will use this kind of different like GUI to work on that, to explore the research questions. Also, let's try to evaluate the research questions more efficiently before actually doing the studies. Apply for IRB to try that. And also, it will happen like in healthcare, in many other domains. For the future world, because this kind of paradigm shift will happen in many domains. So we want to work on some guidelines for this kind of internal AI intelligence design. So because now currently I've only worked on the data analysis. Previously, I'm working a little bit on the design domain, and now I'm working on the data analysis. But I already got some insights on how to work on that. For example, for data analysis, so we need to avoid very command level control, like the executions, because that's a large model. We know large model will do better than us. Yeah, it will know it will know all the things to how to do do the t-test, how to do this kind of model data modeling to do those things. So we just work on this kind of conceptual level is what's the hypothesis we want to give the language model to test. Because for the hypothesis for the high level, we know better the context, we know better the resource, what kind of resource we have, what kind of information we have, what kind of real world problem we are facing. Then for this kind of guidelines for the internal intelligence, we can leverage the domain-specific conceptual elements. For example, for data analysis, maybe the conceptual elements is a hypothesis. Maybe for science, for scientific domains, the conceptual elements is research questions. Maybe for writing, the conceptual level, maybe some outlines, or maybe some avatars, characters, yeah. And then we want to represent conceptual elements as exploration. For example, for data analysis, we want to use some structures, a structured way to present with people how they explore those hypotheses. Maybe for science, that's how they explore the research questions or research claims. And then we want to develop some way to evaluate those conceptual elements with more standard evaluations. But so another thing for the standard evaluation is that because the language model can help all the generative AI can help us to do more. So there will be more collaborations. For example, previously it's just one human, one language model. They are working multi iterations, long tech histories in ChatGPT. But later, maybe as a language model, as a capability is increasing, maybe will there be less interaction iteration between one individual and one chatbot, but maybe more iteration of multi stakeholders, maybe stakeholders from different perspectives, maybe both the clients, the employees, they are all working on with the generative AI, or for example, advisor and advisee, they are both working on the language models. So there are definitely more iterations of the multi-stakeholders, because as people, maybe one individual is their capability is limited, but with more people, with the groups, with the organization, definitely the human collective intelligence is definitely higher. So there will also be some more collaborations, and this kind of standardized evaluation will be helpful to distribute the information. For example, we come up with multiple hypotheses, and we have very good evaluation on that. For example, for the novelty, for the feasibility, and then we can just pass those evaluation to the managers, or maybe we can pass the evaluation of the research questions to the PhD advisors that for this kind of shared context. That's it. Yeah. So that's all. Thank you.